Let's solve Unit 6 Software Engineering questions. Which of the followings are white box testing? What do we have in white box testing? You can derive test cases that guarantee all independent paths within a module that have been exercised at least once. All logical decisions on their true and false sides. Execute all loops at their boundaries and within their operational bounds, and exercise internal data structures to ensure their validity. In this we have path testing and loop testing out of these four options. Path testing comes under white box testing technique to execute every statement in the program at least one time during testing. And regarding loop testing, it is also a white box testing technique that focuses exclusively on the validity of loop constructs. So this testing comes under control structure testing topic. So we can mark option A and option B as white box testing techniques. Option number 1, A and B only will be the right answer. What about the other two options? Black box testing, also called as behavioral testing or functional testing, focuses on the functional requirements of the software. Regarding non-functional testing, it checks non-functional aspects like performance, usability, reliability, etc. of a software application. You have two topics in software testing, namely unit testing and integration testing. We'll get into integration testing. There are four kinds of integration testing: top-down integration testing, bottom-up integration testing, regression testing, and smoke testing. What is regression testing? It is the re-execution of some subset of tests that have already been conducted to ensure that changes have not propagated unintended side effects. After introducing some changes, sometimes the previously working part of the code might not work correctly now. That's what they say, it's the re-execution of some subset of tests that have been already conducted. So those tests are over and the codes have already passed. But this is to ensure that changes have not propagated unintended side effects. It means I have changed some part of the source code, and because of this change, those source code should not do any other work other than what it has to do. They have not intentionally done, but due to the changes in the code, it has automatically happened or accidentally happened, we can say. That is why they have mentioned it as unintended side effects. So we can rule out both C and D from these options because they don't belong to white box testing. Next question, match list 1 with list 2. What is verification? Verification refers to the set of tasks that ensure that software correctly implements a specific function. What about validation? It refers to a different set of tasks that ensure that the software that has been built is traceable to customer requirements. Customer might have given you a set of requirements. We have to validate whether these requirements are fulfilled by the software, whether the software is working as per the specific function or whether it is implementing the function. It is verification. Whether it is working as per the customer needs, it is validation. In software engineering reference book, you could have seen these statements. Verification means, are we building the product right? It means whether the product is built right according to the requirements. Validation is, are we building the right product? So whether the right product is built to meet user needs. So validation is with respect to the requirements of the customer. Verification is with respect to the requirements of that particular product. What are quality control and quality assurance? Quality control means the process of ensuring products and services meet consumer expectation. What is quality assurance? It is about the product quality, the process or set of processes used to measure and assure the quality of a product. So this quality of a product can be equated to the verification part, where they say whether the software is correctly implementing a function and which is built according to requirements. So this part is verification. Regarding quality control, it is about meeting the consumer expectation, which can be equated to validation, where it talks about user needs or customer requirements. A will be mapping to quality assurance. B will be mapping to 3 quality control. A4, B3 is available in 2 places. We can rule out the other 2 options. What about internal logic exercise and software requirement exercise? Let's take black box testing. It is called behavioral testing or functional testing, and it focuses on the functional requirements of the software. So the software requirement exercise is being done in black box testing. What about white box testing? It focuses on the software's internal logic, structure and coding. So internal logic exercise is belonging to white box testing. C maps to 1 and D maps to 2. C1, D2. So we can even rule out 3. Option number 1 will be the right answer. Next question. The cyclomatic complexity of the following flow graph is. Already we have solved in one of the previous year question paper where 5 questions were asked from this flow graph and one of the question asked to compute the cyclomatic complexity. That time we actually calculated the cyclomatic complexity using only one method. In general, cyclomatic complexity can be calculated in 3 ways. In this video, we will be seeing all the 3 ways. Let's see what is cyclomatic complexity. This is a software metric that provides a quantitative measure of the logical complexity of a program. So it can be computed in one of the 3 ways. The first way is to find the number of regions. The number of regions of the flow graph corresponds to the cyclomatic complexity. The second way is the cyclomatic complexity is defined as E minus n plus 2, where E is the number of flow graph edges and n is the number of flow graph nodes, otherwise called as vertices. The third way is to use predicate node method. The cyclomatic complexity is defined as P plus 1, where P is the number of predicate nodes obtained in the flow graph. The first method is about finding the number of regions. Areas bounded by edges and nodes are called regions. When counting regions, we include the area outside the graph as a region. 1, 2, 3, 9 and 1. This area is R1. Then we have 2, 4, 6, 7, 9, 3 and 2 again. This area is R2. Then this area is R3, and they say we have to include the area outside the graph as one region. So the outside area is taken as R4. So R1, R2, R3 and R4. It means there are 4 regions, which states that the cyclomatic complexity is 4. Option number 2 will be the right answer. Now we will get into the second method. We have to count the number of edges, number of vertices and then use in this formula. So let's go to the number of edges. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, this is 10 and this is 11. There are 11 edges in total. E is equal to 11. How many number of nodes or vertices are there? 1, 2, 3, 4, 5, 6, 7, 8 and 9. So instead of the number 8, here it is 10. So there are 9 nodes. Now substitute in the formula. Cyclomatic complexity is equal to 11 minus 9 plus 2. 11 minus 9 is 2. 2 plus 2 is equal to 4. Here also we get the value 4. Now let's go to the third method. We have to find the number of predicate nodes and add 1 to it as per this formula. What are predicate nodes? Each node that contains a condition is called a predicate node. It is characterized by 2 or more edges coming out from it. So when only one edge is coming out of it, it is not a predicate node. But when you have a node and at least 2 are coming out, then that is taken to be predicate node. Now let's find the predicate nodes here. 1 is a predicate node because from 1 we have 2 edges coming out. One is going to 2 and the other one is going to 10 here. We have 2 or more edges. So it should be more than 1 edges. So in that case, one of the predicate node is 1. Then 2 is also a predicate node. From 2 we are going to 4 and then to 3. 4 is also a predicate node. From 4 we are moving to 5 and we are moving to 6. So there are 3 predicate nodes, which means P is equal to 3. From this, cyclomatic complexity can be taken as 3 plus 1, which is equal to 4. Here also you get the value 4. Let's check whether other nodes are predicate or not. Regarding 5, it has only one edge coming out of it. Even for 6 it is the same case. For 7 also it is the same case. For 9 you have 2 edges coming towards 9. But here you have to take whichever is going out of it. 9 is having only one edge to 1. But it has 2 edge coming towards 9. This is not counted. Whichever is going out should be counted. So 9 is also having only one edge. 3 is having 1. 10 does not have any outgoing edge. It has only incoming edge. So there are only 3 predicate nodes as mentioned in the diagram. This is how you have to compute cyclomatic complexity. Whichever way you feel it is comfortable for you or whichever is time efficient for you, go with that way. It is better that you know all these 3 methods. In case if the question turns like how many number of regions are there, how many number of predicate nodes are there, you should obviously know how to find them from this flow graph. Next question, which of the following is not the goal of reverse engineering? What is reverse engineering? It is the process of recovering the design, requirement specification and functions of a product from an analysis of its code. So the source code will be present and by analyzing the source code, we have to recover all these details. The source code is present here. We are restructuring the code. From there we get a clean source code. We are extracting abstractions. So it involves processing, interface and database. All these details can be taken out. Then we go for initial specification. From there we refine and simplify them to produce a final set of specification. This is actually reverse engineering process. What are the goals of reverse engineering? Cope with complexity. You have to analyze complex systems and reveal details about their architecture, relationships and design patterns. The next goal is recover lost information, rebuilding source code, analyzing data structures and retrieving design details. Detect side effects, unintended implications, dependencies and interactions that might not be obvious from the system's documentation or original source code can be found. Certain things cannot be directly seen in the source code or documentation, so those side effects should be found. Synthesis, higher abstraction, makes communication and analysis easier by facilitating a greater understanding of the system's functionality. Facilitate reuse. Developers can extract and repurpose components for use in other projects, improving efficiency and decreasing the development time. We have cope with complexity, option 1 here, recover lost information, option 2 here, detect side effects, option 3 here. The only option that is not present in the other 2 goals also will be option number 4, data flow. So which of the following is not the goal of reverse engineering? Data flow is not the goal. Option number 4 will be the right answer. Next question. The ratio of error found before software delivery and to the total errors before and after the software delivery is called what? Defect removal efficiency is a measure of the filtering ability of quality assurance and control actions as they are applied throughout all process framework activities. How do we calculate defect removal efficiency? DRE is defect removal efficiency. E divided by E plus D. E is the number of errors found before delivery of the software to the end user and D is the number of defects found after delivery. Now just see the question. The ratio of error found before software delivery is E and to the total errors, it means before and after. Before it is E and after it is D. Total errors means we can take it as E plus D. E divided by E plus D is what this statement exactly states. What is it called? It is called defect removal efficiency. Option 3 will be the right answer. Next question. For the software quality assurance, which of the following are correct? Software quality assurance is the process of ensuring that the developed software products have the desired quality. There are some practices that have been followed in software quality assurance process. Let's see them. The first one is standards. Here they are ensuring that standards that have been adopted are followed and that all work products conform to them. In reviews and audits, they uncover errors. Testing is a part of quality assurance. To ensure that testing is properly planned and efficiently conducted, error defect collection and analysis is done. Here we come to know how errors are introduced and what activities are best suited to eliminate them. Under change management, it ensures that adequate change management practices have been instituted. Under security management, they ensure that appropriate process and technology are used to achieve software security. Under safety, they assess the impact of software failure and for initiating those steps required to reduce risk. Under risk management, they ensure that risk management activities are properly conducted. So all these tasks are done in software quality assurance. In risk management, they ensure that risk management activities are properly conducted. Similarly, in safety, they assess the impact of software failure and initiate those steps required to reduce risk. These 2 points say that they do certain steps in quality assurance to prevent some failure from happening. So these 2 points say that software quality assurance can be a preventive technique rather than the corrective technique. They are taking steps to enforce some mechanism to prevent errors from happening. Errors may be introduced at any stage, but here they are knowing how errors are introduced and what activities will be suited to eliminate those errors. So this point, safety point as well as risk management point along with testing can be taken together to say that software quality assurance is a preventive technique. They make sure they don't let the error happen and then go for a correction. They try to prevent errors. So that is very evident in these 4 points. Overall, we can conclude that software quality assurance does not include the execution of the program and it is a preventive technique. In fact, we can confirmly say it is C. Just check what are the options that is coming with C. Only 2 options are here. We can rule out 1 and 4. In B, there is no execution of code and in D, we have corrective technique. Since it is a preventive technique, we can rule out D. Taking this also outside, we can be evident that option number 2, B, C only will be the right answer. We have to ensure that testing is properly planned and efficiently conducted. So the team has to analyze the testing process. They are not going to test it. Similarly, error defect collection and analysis is done. They are asking how errors are introduced and what activities they have done. They are not going to sit and correct the error in the source code. So execution of code will also not happen here. We will go with option number 2 as the right answer. Next question. Arrange the following so that they can be placed in perfect or appropriate order. Software process has these 5 phases: communication, planning, modeling, construction and deployment. Communication is in D, planning is in A, modeling is in C, construction is in D and deployment is in E. D, A, C, B, E. Option number 2 will be the right answer. Now let's see a word about all these phases. Communication is to understand the stakeholders' objectives for the project and to gather requirements that help define software features and function. What is planning? The software project plan defines the software engineering work by describing the technical tasks to be conducted, the risks that are likely, the resources that will be required, the work products to be produced and a work schedule. All the related plans are coming under this phase. Modeling is to create models to better understand software requirements and the design that will achieve those requirements. Construction is to combine code generation that can be either manual or automated code generation, and the testing process that is required to uncover errors in the code. So code generation as well as the testing is combined under construction. In deployment, the software is delivered to the customer who evaluates the delivered product and provides feedback based on the evaluation. Under software process model, they will actually explain all these phases together, and based on the type of software process model, they will draw different diagrams. Say for example, in spiral model, all these phases will be arranged in a spiral way. In waterfall model, it will be arranged in a linear way. So based on the type of software process model, these phases will be diagrammatically arranged in a different way, but this is the order of the phases overall. With this, we are completing Unit 6 solutions.